Howdy, folks. My name is Arul Verma, and this week in CS 120 Honors, we're going to be going over Structs Part 2. So our goals for today is to review some information about structs. We went over structs very in-depth in Lecture 8 last week on Thursday, but we're just going to be kind of reviewing some information, going over a little bit of new information, and look at some sample struct code to get a better understanding of how structs work. So let's do a quick overview. What is a struct? A struct is a custom-made data type that holds multiple values, so it can hold strings and integers at the same time. It's very similar to tuples in that sense, in that you can hold multiple data types without an issue, but unlike a tuple, you have to declare the data type that you're storing. You cannot implicitly declare that data type. An object of a type struct is called an instance of that struct. You'll hear me use the word object and instance both interchangeably, so be aware that I'm referring both to the same thing, an instance of that struct. Structs are functionally very similar to classes. Instances do not share variable data, so unless you declare the variable static, the variable data is not shared across instances. And you can declare local functions using traits and impl. And impl allows you to create methods for your struct that you can access at any time using instances. And generally, you declare structs and classes prior to the methods they're used in. However, that's not necessary in Rust. So how do I create a struct? Well, the keyword there is struct. So you just create your struct using that keyword. Then you use the name of that struct, and you use curly braces to indicate where your struct starts and ends, and then you fill in all of your variables, along with their types, and you comma separate. It's very straightforward to create a struct, and creating an object is not much different. You use the keyword let as if you're creating a variable, the name of your struct, and equal to the name of your instance, and then equal to name of your struct, curly braces, and then you fill in all of the variable spaces. The one thing that structs have that really separates them from tuples is that structs can edit their inherent data. So you can say that I want to edit my email, and all you have to do is make your instance immutable, and you can change it using dot notation. So it's very straightforward, and it's something that sets it apart from tuples in that sense. But otherwise, structs are very straightforward. They allow you to access and store data. And the other important thing to know about structs is to create methods or functions for them. So say you want to go about adding a function to your struct. The important way to go about doing it is to use the keyword imp. So before you start, you need to have this hashtag derived debug. And then you use a keyword impl or implement to indicate that you're going to start implementing a function for your struct. You can have multiple impls for the same struct, and it's a useful way to separate your associated functions from your functions for your struct. And I'll go over what the difference is in a minute. But structs are, that way you can sort your functions and make sure that you use the appropriate function in the appropriate area. So functions for your struct generally that are accessible by your instance, that is, and take borrowed data from your instance, pass the ampersand self to let the function know that it's being called by an instance and it's taking instance data in order to call itself. So this ampersand self says that I'm passing the instance that's calling this function, its data into this function. So I can access its width, I can access its height, in this case for this rectangle, and then I can do something with it. If you wanted to pass a mutable reference, you'd say ampersand mute self, and that allows you to pass mutable data from your instance and allows you to change that data for your instance. All methods in your impl that are supposed to be called by your instances must pass the ampersand self, irrespective of their use. The only exception to this is your associated functions, which I'll be going over in a minute. So this is some sample code for what a struct looks like. So we have our struct rectangle. We can see it has our fn area that we saw earlier. And this is an improvement over the previous one, where we have a function can hold. It's a new function. All it really does is to check if one rectangle can fit inside another. And you'll notice that the first one takes ampersand self. It indicates that it can be called by a instance, not just the class itself or the struct itself. So in any instance of type rectangle can call this function can hold. And the other parameter is an ampersand rectangle. So we're taking another rectangle instance, and we're going to be doing something with the two pieces of data. So this is how you indicate that you're taking another instance other than yourself. You just take the struct name, and then you do ampersand. You can also use ampersand capital SELF, but I just recommend using this syntax instead. And if you want an idea of what the capital SELF is, you can go watch my previous lecture, and I'll go over it in a little bit as well. So just doing it this way, using your borrow, allows you to access the data of your instances. So you can see we compare self width and other width, and self height and with other height. And we can access the data because these are borrows, and they refer to an instance. So it's borrowed data from an instance rather than borrowed data from the class itself. Or sorry, the struct. I use those words interchangeably. Please know that I don't mean to. Structs and classes are not the same. I say them out of slip of tongue, but structs are different. And in this case, we are referring purely to structs. So here we have three objects, rectangle 1, rectangle 2, and rectangle 3, each with different pieces of data. And we can call rect1 can hold, and we don't have to pass rect1 when we're calling it with rect1 dot, because rect1 is implicitly passed to this can hold call. The only parameter we have to pass is rect2, which falls under our other in this case. And same with the second one, rect3 falls under our other. Our self is always the caller of the function. So rect1 is always the caller of can hold in this case. So now let's talk a little bit about associated functions. I did say that all functions need to pass ampersand self as in your functions when you're using impl, but there are exceptions, and that is associated functions. Associated functions are functions that are not called with dot notation, but instead with the struct name, colon, colon, and then the call. So in this case, we have, if we were to call this function square, it would be rectangle, colon, colon, square, parentheses, whatever data we want, and that function would return an instance. And we can see that because of this arrow. It doesn't necessarily have to return an instance. It really just depends on whatever this return value is. This is typically used for constructors, and that's the most common use case for associated functions. So in this case, it would return a rectangle instance. And what that means is that this capital SELF, you'll notice, is different from the ampersand self from before. It's just saying that you're going to return a type of that struct. You're going to return a type of rectangle. So this is returning an object of type rectangle, which in this case would be an instance of rectangle with width equal to the parameter, which is also equal to your height. So self is an alias for rectangle, as I said. And yeah, the best use case is constructors, but you aren't limited to that. So you can definitely use associated functions, but the most common use cases for constructors, and we don't recommend using it outside of that in general. So the one thing I didn't really cover in my last lecture are tuple structs. And I kind of glossed over them, or I didn't even mention them just because I didn't see use for them, but I think it's important to let you guys know they exist. Tuple structs are functioned the same way as a tuple, and you can access data much in the same way that you can access data in tuple, which is dot notation. So this just creates a struct called color, which accepts 3 integers in a tuple format. So they are immutable, and this kind of setup allows you to distinguish your tuples so that your tuples can't be passed indiscriminately through all of your structs. So say I had a very specific function that wanted a tuple of type color. This way I can know that every struct I'm passing to that is a color. It's not a point in like an XYZ coordinates. Instead, it's RGB, which is 256, 256, 256. So it allows you to distinguish your tuples of interest and indicate that they have something special about them, or there's a way of storing them that's important, or the data they store, basically. And they're useful in certain cases, but generally I don't see much use for them outside of just tuples in general, and they function very much in the same way as tuples do. So that's all we're going over for this lecture. I didn't have too much because a lot of the information I was going to be going over has been covered in the previous lecture. So it's been really short today. The only things to know is that Homework 7 has been released and MP2 is releasing soon. It will be focusing on structs and object-oriented programming concepts. If you want a much deeper dive on struct theory and how structs work, review lecture 8 because it goes very in-depth on partial comparisons, copying your structs, cloning them, or even just using structs in general. And if you want to go over the struct information in general without going over the lecture, read chapter 5 and the rest docs. So yeah, that's mostly all for today. Before I go out, I just wanted to share a little bit of example on Rust and their by examples on the website, just to show you what the textbook looks like. So you can see that they have a very nice setup for structs here. They have like a unit struct. They have a struct setup with drive debug. They have a struct setup with tuple struct, just a struct with 2 fields, and then a rectangle that we talked about earlier. And we can see how they've set up the entire struct in a way that's like very friendly, and they have comments explaining how everything works. So I'd highly recommend looking at the Rust documentation because they're very in-depth. They also have activities for you to practice using structs on your own. And of course, if you have any questions about how to do these activities, you can always contact us in Discord for help. So yeah, that's everything I have for today. Thank you so much for listening, and I hope to see you guys in the next lecture. Bye.